Hello everyone, I'm Christopher, the Conan developer advocate over here at JFrog, and I'm thrilled to get to present to you what's new in Conan 2.0. My involvement in Conan began almost 3 years ago as an open source contributor and enterprise user, and I can assure you you'll be just as excited as I am when you learn what's coming. Everything is new. It's been 5 years since the 1.0 release without any breaking changes. About 60% of the code is completely new, from scratch, all new. And this is going to really bring some huge improvements to Conan. 20% of the code now is backports, and that's what's the most important part for you. One of the main principles that guided the 2.0 work was to provide a compatible syntax in the 1.x to help smooth that transition and adoption to 2.0. Another huge principle was feedback from users. You can start to see just how vibrant and active the Conan community is. With just this snapshot from the C++ language Slack, you can see Conan is ranked number 2 in the number of members who posted message, and it's the top 3 for how many messages there actually are. The social engagement. Even looking at usage, Conan has gotten nearly 700,000 downloads from PyPy in the last month. We've also gained the PyPy Critical Project designation, which marks Conan as one of the top 1% projects even in the Python ecosystem. And that's not the whole picture. This is just one of the installers that we offer. There's also an MSI for Windows users, Brew for Mac, Debian, etc., and you can check the full list on the website. Being an open source project, we can also look at the contributions over the past few years. You can see in 2019 there was roughly 750 pull requests to Conan, which is like the main client portion itself, and that number has remained strong over the years. But what I am proud to share is the number of pull requests in Conan Center. This is where Conan users get to contribute open source projects they need to make them available for everybody. There has been an astonishing amount of growth, and as a community reviewer, this graph doesn't show and capture the enthusiasm that I see from contributors every day. In 2021, we saw well over 3,000 pull requests, and this year we're set to make over 4,000 already. And this is just so far. We're seeing about 150 to 200 pull requests every single week, so I think we should hit that 5,000 mark this year, and that should be pretty freaking sweet. Contributions are amazing and helpful, but we also need to talk about support. Users have questions, issues, bug reports, and we see around 2,000 GitHub issues per year. We spend over 100 hours in video calls with customers, and we have almost nearly daily requests that are messaged directly to us asking for help and guidance. You can see in the graph we have a growing number of JFrog Artifactory servers that use Conan in production as well. And these are just the servers with telemetry enabled and that are not behind a firewall. We have these amazing users actively using Conan in production as part of their daily workflow. These Conan experts who happen to work for companies like TomTom, RTI, and Bloomberg, just to name a few. The Conan tribe has been invaluable in helping us iron out the details for the Conan 2.0 launch. Their practical expertise turned into feedback for development for these new features that I'll be sharing. Today I'm going to be going over the 4 lessons we have learned from the C++ ecosystem and how we've incorporated this into Conan 2.0. Our first lesson is learning to fly. The initial takeoff point for Conan is really understanding the dependency graphs in the C++ ecosystem. We need to start off with a Conan file, or what we like to call a recipe. This is the instructions for getting the source files, building the project, and packaging it in a reusable way. You can also set attributes for the Conan file class, like the name and version in this example. So with this math project, we are using the Conan create command to make a binary package, which we will typically include the library archives and header files that we would expect to have if we built another project on top of that. Surprise! The requirements have changed, and now we're trying to make a game that requires an engine, which uses the math library, which we just saw. You can see these dependencies in the Conan files requires attribute. Now let's say you were working locally with Conan 1.54, you ran the Conan install command, and that CMake deps generator you see would have outputted the configuration files for finding all the dependencies in the graph, even the transitive ones. But what would be your expectations if the engine library was built to share? If the engine correctly encapsulated the math library, we would expect the game to no longer require math binaries. This sadly just isn't possible in Conan 1.x. Currently, you would have to get all the transitive dependencies, even though linking to a shared engine would already include the math symbols. More so, because the math libraries and header files were exposed, developers could erroneously use them from the game when trying to, without explicitly having a dependency on them. So why is this a problem? We could just not always link statically? Well, unfortunately, the answer ends up being no about 25% of the time. Some of the cases we often come across are long link times, accidentally embedding unused copies, bloating the binary size, just to name a few. So this is the Conan 2.0 proposal. If this looks familiar, it's because it's the same as Conan 1.x, and you could run this without any error in Conan 1.54. Yet, we have added in 2.0 our requirement traits. You can now explicitly set if the requirements include headers, libraries. By default, both are true, and this opens the door to possibilities. So when both attributes are true, the CMake config files generated by Conan includes both the link libraries and the include directory definitions for the math library. You can see them here in this example. If we were to explicitly set headers to false, this would mean the engine project does not need to include any headers. The Conan generators would only populate the link libraries, omitting the include directories. This way our engine would not be able to access the header files of math. On the other hand, if we were to set libs to false and leave headers to true, our engine project would only have access to the header files through the generated configuration files. With this new informational flexibility, we should be able to gain access to a better model graph. When looking at our graph in Conan 2.0, we can see there are direct and transitive dependencies now. Our engine recipe has a direct requirement for math. Our game still has the direct dependency on game, which also includes the transitive dependency for math. Now in our engine, we can finally change it to build only as a shared library. We could explicitly tell Conan our requirement to the math library will not be exposed by setting the transitive libs property to false. This will allow Conan to build our dependency graph such that game will now have the transitive requirement of math with headers and libraries set to false, meaning the client will not expose the include directories or the link libraries when generating our find config files. This will prevent the library from being passed at link time, avoiding any penalty to the size which would have been incurred with Conan 1.x. Also, if developers were to use math in-game, they will now need to explicitly add a direct requirement to math. In order to simplify this and to provide some reasonable defaults, we've also introduced the concept of package types with Conan 2.0. This is one of those features that was directly influenced by the Conan tribe. There are 3 package types which we have defined. They are static library, shared library, and application. For the 2 library types, they can be determined by using the predefined shared option. Depending on the value being true or false, Conan will be able to generate and correctly pass the requirement traits. Now I'll switch over to doing a quick demonstration of this. So before we get into our very first demo for this evening, I will be going to explain one new Conan 2.0 feature that I'm taking advantage of. So you might notice here I have this conan.rc file, and this is a new feature which allows each project to specify explicitly the Conan home folder. So previously in Conan 1.x you could only change this with environment variables, but you can see here I am going to do this relative to my current directory. I'm going to have a Conan 2 home folder, which you can see is already here, and there are already some settings and profiles defined. So if we go over to my terminal, we can type Conan version, and you'll see here I am running the latest beta 5. Clear. Now so as you can note, we are already in the game subdirectory. So what we'll do is a Conan install, and we will specify our option as engine shared equals true. Now, if we go up just a little bit, you can see here it's computing the necessary packages, and engine was found in the cache. I had pre-populated those, but the most important one here is math skipped. So this is how Conan is showing you that it knows that the math requirement was not required. So if we go into our build generators folder and we look down the list, you'll notice we have only the engine configuration targets which are required to load with the cmakeFind package, which is this guy over here. Now, if we go back and we do this again without our shared option, so just with engine as static, that is our default, you'll notice it's pulling up math from the cache this time because it knows it needs this dependency. We go into our build folder and we go into our math cmake target release. You can see there's all the things that are populated, and here if we look at the paths that are being populated, you'll notice here we have the library directories, which is being populated here, but the include directories are empty because the assumption here is that as a shared library, it should be encapsulating all the dependencies, and only the link libraries are required. With the improvements to the dependency graph in Conan 2.0, we can now express correct linkage requirements, correct header visibility, and possibly even have hidden or private dependencies. And this is just scratching the surface. If you want to learn more, I highly recommend Diego's talk focusing on this and package mode improvements at the ACCU conference this year. You can find that one on YouTube if you're interested. Our second lesson is going to be building a dam. And building a dam is just the beginning. You can also need to generate electricity and deliver it to consumers. It's no secret humans don't like change, and we have conversations that go like this. I want the libs from Conan dependencies in my project folder. Us. No need for it, you can just use the libs from the cache. But the dependencies should be in the project. Not really. Many other package managers like Maven, pip do not put the dependencies in the project folder. But it's easy, they say. Why don't you just put the dependency libs in my folder? Us. It's easy that they'll conflict and have different versions, the binaries might not match, there's no metadata, no synchronization, and then you're taking up double this disk space. And they finally retort, I want the libs in my project folder, they should be there. Yay. All jokes aside, there are some pretty valid use cases where something like this could be really beneficial. And we'll be introducing deployers with this new Conan 2.0. There will be two built-in deployers, full and direct, but this is just the start. Deployers are extensible. You can write your own, install them using the same Conan config install commands you're probably already familiar with, just passing a URL or path. These custom deployers only need to define a deploy method and have access to the Conan file, so you can access exactly what you need from the package or even go over the entire dependency graph. I will be demonstrating this here with you now. So for our deployers demo, we are going to pick up right where we left off for the graph demo. So I will clear my screen. You can see we're still working from the game directory. And let's say our local game developer wanted to do that full eject style workflow. He could do Conan install, and then he can do deploy full deploy. So that would have done our install. So now if we go into our game folder, we not only have a build folder, but we also have a host folder. So here is our generators, which should look very familiar to the last demo. But we also have our host engine, and this has all of our things. So we have our name, version, debug type, and our architecture. You can see we have an include directory, build directory, as well as the info files. And you can see math has a very similar structure. Now if we go to our generators and we pick, for instance, the x86 for our engine, you can now see it's pointing to our user Conan what's new game host engine, and this is the actual directory in my local structure. So for those who wanted to have Conan run and work with the local directory and have everything locally in their own file, they're now able to do so. Now, having a deployer that just ejects all the content in your current directory is great, but I think one of the more interesting use cases is how we can use deployers to create a installer. Now, if we go over to Visual Studio again, and we look, I have a deployers folder that has a .conan folder. Now, this is my own naming convention, and I think it goes nicely with the .conan RC. I have my extensions deploy, and I have a runtime zip deployer. Now, you can see here, this will search in different directories, and it'll look for our shared runtime and executables, and it'll package them in a zip file and give us that as a target. So these are very easy to work with. If we go into our deployer folder, we can show off this cute little demo by doing Conan config install.conan, because that's the directory we want to install. And you'll notice here it'll say copying runtime zip deploy to our Conan home directory, extensions deploy. So now if I do Conan install, and we're going to do a virtual graph, so we're going to explicitly require our game 1.0, and we're again going to do our engine shared. Now we're going to specify deploy and the same file name that we gave our deployer. So you'll notice it would have done our lookup. So we have our game, we have our engine, and math, which in this case was skipped because engine was shared. So if I go back to Visual Studio and we open our deployers, now you can see a lot new files. So these are the regular files that you'll see from our environments, because we're using virtual build and virtual run environments. Those are generated here, but most importantly, we have our zip file. Now, if we reveal in Finder and we open this up, we can go and check, and we have both our game executable and our shared copy of our engine. And you should be able to run these and it'll work without any hitch. So that should give you a taste of what deployers can do. They are a flexible way to extract artifacts from the cache. In addition, they allow automation of post-Conan tasks like creating installers. They are also not part of the recipe. Unlike the previous Conan 1.x imports mechanics, each recipe needed to have its own import method with the logic implemented specifically for it. The new feature will enable scalability, deployment across many packages. The user can provide their customized way to extract exactly what they need, and these deployers can be installed with the Conan config install command, as a lot of the other options. The third lesson makes me feel a touch guilty. It's death by 1,000 bytes. And this is our expression for the burden directly implementing specific use cases and workflows that we've been asked over the years. There was a Slack message on the community channel about one of the more common helpers, files.get, which is used to download and verify archives, so the source files of different projects. The author was asking why there was just so many arguments to this one function, which should have been relatively easy. He discovered an old GitHub issue which made it clear how we got so many args. Clicking on the link and following it, it was an issue I created as an enterprise user trying to meet my own specific needs. Of course, it had to be one of mine. The solution to this problem is quite simple, actually, which is usually a good sign, right? Just allow users to help themselves. With Conan 2.0, we have worked hard not to provide just a tool, but also a framework. A framework which allows users to build solutions tailored to their needs. We are launching with several supported plugins. In today's talk, I will focus on the profile, command wrapper, and package signing plugins. The profile plugin allows checking, validating, and manipulating of profiles. In order to understand the need for such a feature, though, we'll need to look back some of the challenges developers face today. Let's build our game example for the local developer system, given the profile of Linux with GCC version 8, and they're using C++20. But let's say the team builds, tests, and ships the game for multiple different compilers. We want to be able to move forward and update the compiler versions regularly, so we're more agile. So we want to have a profile that allows us to build a certain set of compiler versions. And we can do this with profile templates. Since Conan 1.38, this has been supported and uses Jinja to render these templates. This enables an easy workflow where we only have one profile template which takes in several environment variables. You can note that OS get env call in our profile now. This will allow us to dynamically change the value to match the development environment that we're using. So let's say our developer needs to work on an older compiler and changes his environment variable. In his terminal, he punches in my GCC version equals 6. So the profile passed to Conan would then be using GCC version 6 with C++20. Now this should not actually work. C++20 support was not added until GCC version 8. So this could result in compiler errors about unknown flags. So what can we do to ensure that these profiles being used are valid? I'm sure you can imagine other situations where only a subset of the settings in Conan should be used for a particular project, and it would be beneficial to make sure unsupported settings are not being passed for local development or testing. So let me introduce the profile plugin. Similarly to the deployers we saw earlier, these are also installed in the extensions folder using the Conan config install command. However, this uses a different method name, profile plugin, and pass the complete profile to the method before loading the graph. There are a few built-in checks done by this plugin. One to ensure the CPP STD is valid given the compiler version, the example we just went over. In addition, there is a second check to match the MSVC compiler runtime to the build type being used when it's absent from the profile and settings. So we are recreating our example on my MacBook. I have my normal profile with Apple Client 14 using C++23. However, with my profile plugin, if I specify a compiler version equal 12, I will get an easy to work with error message. The provided compiler cppstd equal 23 requires an Apple client greater than or equal to 13, but version 12 was provided. And this allows me to correct the issue. I know exactly which setting is wrong and what value it needs to be. Now changing gears, not only can we validate settings, but we can also fill in the blanks. For Windows development, we often don't think about the different runtimes we're using, unless we have to, that is. The typical default for compilers and toolchains is to match release and debug compilation with the same runtime optimization. In other words, building an optimized application will link against an optimized system runtime. It is, however, possible to mix them. You can build a debug application using a release runtime, and there are various benefits to doing something like this. This is what the second part of the build profile plugin will do. When the settings for a compiler runtime is not set, it will be assigned the same optimization for the build type. That means changing from debug to release for the build type will also change the target system runtime that will be linked against. So, Just to recap, the profile plugin allows you to control the content in a profile, and there are two built-in features of the profile plugin. The first is to ensure that the CPP-STD is supported by the compiler version, which is an example of just validating the profile is coherent. The second is to ensure the compiler runtime matches the build type. When it is not specified, this serves as an example of manipulating the profiles, which is the one we just covered. Of course, these behaviors are completely optional and extensible. You can modify the default roles to the specification or build your own to enforce workplace or project-specific conventions, constraints, and compliance. This is one plugin I am most excited to see what users will be able to achieve, what problems it might help them overcome. The plugin I will be sharing is the command wrapper. This was intended to support external tools like Incredibuild, which need to be added to certain commands. The command wrapper plugin will be called each time self.run is called, and this is the entry point for Conan invoking things on the shell or command prompt. You'll be given the exact same command line before Conan runs it, and you'll be able to manipulate it however you like. For a theoretical example, let's say you use Ccache to speed up build times. With modern CMake, you can set a compiler launcher, which is prepended to the compiler invocation. So here, each time Conan calls CMake, we can make sure to set variables for CMake's compiler launcher as Ccache. So when CMake is called, it will always know to use this tool. This is far more convenient of a solution than trying to modify each and every single project or multiple projects to change to use Ccache in their build scripts or even adding options to support doing so. It can be applied to the entire dependency graph using this plugin without modifying any of the underlying projects. Arguably, the most important plugin I will be introducing is package signing, which I believe has the most chance to bring innovation to the C++ ecosystem. Supply chain security has been an increasingly important topic. It's important to have traceability. Given Conan distributes binaries, it's in the right position to make a huge impact. This is a question we get very often from prospective users. Typically, most companies already have already implemented this in some internal mechanism, and this plugin will allow them to seamlessly add it into their Conan packages. That being said, open source is extremely important, and we're also working on some very exciting integrations, which will be coming shortly after the Conan 2.0 launch, so stay tuned. This diagram should look familiar by now. As the other extensions and plugin, you simply need to provide one file which can be installed as before. The package signing needs two methods, a sign and a verify method. They are called for a single reference, think project, and have a few arguments which I will explain. The important thing to note here is when this plugin is called, this is specifically for when the client is interacting with a remote or registry, some package hosting server external to the local client's cache. Simply creating a package will not sign it. If you build it locally yourself, hopefully you trust it. So our two plugin methods are called when uploading packages to a remote. This is when the sign method is called. And given a reference and artifact path, you'll be able to perform the necessary calculations and save the output, which is most likely a signature, to the signing metadata folder in the cache. When consuming packages, for instance, when a Conan install is called, when the packages are not in the local cache and a match is found in a remote, the verify method is called of our plugin, which will be called with the same parameters as before. This will allow us to compute the signature with what was downloaded and verify against that which was previously captured in the cache. And I'll be demoing this for you shortly. It's worth mentioning because this is in Python. You can very easily call a program to upload the signature to a central server or download the new ones to verify with. So for the package signing demo, we're going to start off by looking at Visual Studio Code. And we have a package signing demo, and we have our .conan folder. We have our extensions, plugins, sign, and our sign.py. And this one simply just goes through all the files in the artifact folder and then creates a signature for them. And the verify does the same thing. So it's going through looking for the signature and then making sure the contents match. However, this one has one extra detail, which is a extra remotes.json. So this is where we're going to be adding and uploading our packages so that we can then pull them down to verify. And this here is in my JFrog instance of Artifactory. And there's a bunch of them already in here. So if we grab our terminal and we go into our package signing folder, we can do a Conan config install.conan. That's done. We can then do a Conan upload. Now we're specifying our JFrog, which is the remote we want to do. -C is just to skip the confirmations, and -F is because I have a bunch of junk in there. Force. So you'll notice it's signing a bunch of different artifacts, and printing the references, and then it's uploading them. Now, if we clear, we can do a Conan remove everything. Yes. -F. There we go. Flush that out. So now there's no packages locally. Now, if we go back up and we do Conan create game and build missing, now it'll start looking for the packages, and you can see it doing the verify. So for some of the packages, like engine, which it was able to find with JFrog, it was able to download and verify those signature contents. With these new plugins for managing profiles, commands, and signing, users will have a real framework to build on top of. I do not share custom commands or the new Python API coming in 2.0. I highly recommend watching Diego's CPP Con talk for those highlights. Sadly, it's not yet available, so you'll have to subscribe to that YouTube channel. We have also been working on packaging signing for Conan Center, and we have some really exciting integrations we've been working on. You might want to follow us on social media. The last lesson we will be covering today is repeating yourself. How or how not to be repeating yourself. Depending on your use case, you can choose. This can be extremely beneficial as a way to achieve reproducibility, repeating the same build tomorrow and in 10 years from now. It's something many of our clients have a business requirement, a legal requirement, and an obligation to do. But also reusing existing valid binaries, correctly capturing the binary configuration, and knowing binary compatibility between packages is often just as necessary. When we hear about binary compatibility, we often get mixed up because it can mean different things to different people. So let me explain what it means from a Conan perspective. We have two of our projects, Engine, which requires math, each have their own package. Each package has a unique ID that is generated from the settings, options, and the graph it was created from. Regardless of the compatibility, we can pin a binary to exactly the one configuration it comes from. If another package exists for a different configuration, its package ID must be different, or else Conan would not be able to distinguish those two configurations. Now, if these two packages are compatible, that means downstream consumers of those projects are able to fall back to a package which is not an exact match for the requested settings. This means Conan can look for other package IDs when the exact one does not exist. So what do these settings and options look like? You can see here an example from the recipe of FMT, which is in Conan Center. We have a collection of settings and options, and we often refer to this as the binary model of a package. Any change to one of these will cause a different package ID to be assigned. The relationship between options is also important. The header only and shared options are mutually exclusive, and that's modeled in this recipe. But there's more. Conan also has different package modes, which can change how the package IDs are computed. So there's a lot of nuance that is specific to each graph. But let's take a step back and talk more generally. Binary compatibility in Conan means different package IDs of different dependencies can be used to create the same package ID of the target project. So different input gives the same output. If we reuse our math and engine projects, we should be able to demonstrate this idea. We have two math packages, 6a and 2.3, and we need to build our engine with an ID of 79. If the required package for our profile is 6a for math, that package will be used since it's an exact match. Now, if that was not the case, let's say both packages used a different minor release of the compiler, so GCC 7.2 and GCC 7.3 respectively. And now let's try building engine with GCC 7.4. If our compatibility policy is to look in reverse order of our minor releases, so of the compiler, so 7.4, 7.3, 7.2, then the math 2.3 would be the selected to satisfy our graph. So since that example is a bit long, let me give you a real world example instead. One of the long-standing issues I've personally been very interested in is the management of libc versions with Conan, where there is a backwards compatibility. If you build with glibc 3.28, you can reuse 3.23, and this would still output a 3.28 glibc ABI, regardless of which versions you are building your dependencies with. So hopefully that gives you a good idea. With the compatibility definition understood, let me introduce yet another plugin. I'm sure you are starting to see Conan as more of a framework for managing your dependencies now. We have compatibility, which is located in the extensions folder, similar to the plugin profile. There is only one binary compatibility that will be provided by default. Packages can fall back to any CPP-STD value. As we saw with the deployers, the plugin gets a Conan file, which means you can access all of the dependencies, settings, etc. It's also worth noting, this acts as a migration helper between 1.x and 2.0. The CPP-STD value must be specified in 2.0, where it was not required in 1.x. So the default behaviors will be similar in practice with this default built-in compatibility. And this is what I'm going to demonstrate for you now. For our final demo, we're going to be going over binary compatibility with CPP-STD that is built into Conan 2.0 by default. So if we do Conan profile show -pr default, you'll notice we are going to be running with CPP-STD 11. And that's going to be our starting point for our first few projects that we're going to build. We check in my cache. I don't have any packages yet, so we're starting with a clean system. So the first thing we're going to want to do is build math. So we're going to do Conan create math version 1.0 build missing, and we're going to specify our default profile. Just this guy over here, which is the one we just saw, which is our CPP-STD 11. We run this, beautiful, and then we can do it again, but this time we'll do it for engine. You can see it compiles. If we flick over to Visual Studio to look at our cache, we can look at our packages. This one is in 14E. So if we go to 14E, package, Conan info.txt, you can see here our settings have our CPP-STD 11, and this has the requirement on math, which is very cool to see. Now, if we want to do Conan create game, this time specifying our compiler as CPP14 over here, and we run this, if you notice, we're only going to see one build arguments. And if we scroll up a little bit more, we have computing dependency graph. You can see here all the things were in the cache. And here is computing necessary packages. And you can see here for math, it's checking 11 compatible configurations. And you can see here it started with C++ 98, 11, and then it found a matching binary, so it stopped looking. And then here, we have the same thing again, but for engine. And it stopped, it did not find the exact match, but it did find a compatible one, which is the one for CPPSD11 over here. So our 3.2, and then we have the same one here. Now, if I do a Conan remove everything, and then we build math for default, and then we'll do our engine again, but this time with 14. And we do -s compiler cppsdd equals 14. It's built. Now we can do Conan create game with our cppsdd14 over here. And this time if we go to computing necessary packages, you'll notice only math is being searched for now because game already had the because engine already had the exact match, so it did not need to do any searching. So what have we seen so far? Why Conan 2.0? Your feedback. We've been listening to all the feedback you've been and have worked tirelessly to come up with better solutions. Some of the key features to do this: the new graph resolution model. We've added requirement traits to better model how binaries are captured. We've added applications type to provide good defaults for the graph to use. We looked at deployers. You can finally eject everything into your current directory if you so wish, and you can create installers in a fashion that is much more scalable. I've also introduced countless new plugins for you to explore. We have the profile plugin to validate or even change profiles, command wrapper, so you can inject anything into the command line, which would be much easier to deploy new tooling instead of modifying individual project build scripts. We have package signing. You'll finally have traceability throughout your build and which artifacts are being pulled in. Lastly, there was the Compatibility Plugin. This will allow you to have reproducible builds with exact settings while opting into managing binary compatibility, if you know a different setting could be used in place of a matching one. And this is only scratching the surface. We have many other improvements with Conan 2.0. Some of my favorites are multi-revision caches, lock files, and custom commands, which will drastically improve my CI/CD pipelines for my projects. And I hope you're just as excited as I am for the pending 2.0. If you want to try it out yourself, we're at the 5th beta. Installation instructions are very easy, just pip install. As for when it'll be out, we suspect there will be a 6th beta before we hit a general availability release, so stay tuned for that. Cheers, everyone.